This last example for the chain rule is something a little bit different. We're going to evaluate derivatives using tables here. So this is kind of an interesting new idea. But we're starting with these functions. I have two of them. I have h of x equals f of g of x, and then I have r of x equals g of g of x. I'm going to use the tables that are given below here to evaluate h prime of 2 and r prime of 3. So let's start with h prime of 2, h of x. We're going to do that in blue. H of x, just to restate, is f of g of x. Before I jump straight into let's find h prime of 2, I need to find the general h prime of x. I need to find the derivative of this function. All right, here I have a composite function. I have g of x, which is inside of the f of x function. So I have a few options. I could kind of fall back on that four-step process and say, okay, u is equal to g of x and blah, blah, blah. But I actually think that's more work than we need to do here. Because when we write h of x equals f of g of x, if we go, and let me see if I can go all the way back to the very beginning definition, we said, hey, if you're working with the derivative of f of g of x, that's simply f prime of g of x. And let me erase some of this so that we can actually read it. We said, hey, the derivative of f of g of x is really f prime of g of x times g prime of x. So we can use that same notation for this example. So let's go back down. So the derivative of f of g of x, think about this here. It says the derivative of the outside part, so f prime of x, inside part stays the same, so g of x, times the derivative of that inside part, g prime of x. So here's my derivative. I just used my chain rule. And now I need to evaluate this function, h prime at 2. So I'm really looking for f prime of g of 2 times g prime of 2. I'm plugging 2 in for x here. So first I'm going to look at g of 2. So right here I have an x value of 2, and g of 2 is equal to 4. So that's this guy right here. So I'm going to say this is really f prime of 4 times, all right, well now I need, oops, shoot, I just wanted to get rid of the highlighting. Let's do that. Okay. Now I need g prime of 2. Well, g prime of 2, that is negative 4. So g prime of 2, that is negative 4, so times negative 4. And I'm not out of the woods quite yet, because now I need to look at f prime of 4. So my input here is 4. What is f prime of 4? Well, that's really negative 5. That's this guy right here. So I'm going to take out f prime of 4. That would be negative 5 times negative 4. We can multiply these two together to get a positive 20. This is my h prime of 2. So all right, there is my h prime of 2. I also want to work with r of x, so let's do that in a different color here. R of x, we said, was g of g of x. This looks a little bit funny because you have one function inside of another function. So r of x, we said that was g of x. So when I take the derivative, r prime of x, we can still use that chain rule, that kind of general version of the chain rule. G prime, derivative of the outside part, inside part stays exactly the same, so times, g prime of g of x, times the derivative of the inside part, times the derivative of g of x, that's just g prime of x. And I want to evaluate r prime of 3, so 3 is my input. So r prime of 3, this is equal to g prime of g of 3 times g prime of 3. So let's look at g of 3 first. When I have an input of 3, g of x is equal to 1. So g of 3, that's equal to 1. So this is really g prime of 1 times g prime of 3. I can look at that. When I have an input of 3, g prime of x is really negative 1. So times negative 1 is my output here. Still need to go find g prime of 1 though. So let's go back to our table. G prime of 1. Here's my input of 1. I'm looking for g prime of 1. That's going to give me back 10. So this is really 10 times negative 1, which gives me negative 10. This is r prime of 3. So I think this is a really neat example. We won't see derivatives using tables like this all that often, but I think it's a really neat example that does a good job of illustrating that we are working with a set of composite functions. We're working with a function inside of a function, which is really kind of why we have the chain rule. It's the whole point of the chain rule, is it tells us how to take derivatives of composite functions.